Welcome to lesson 12 on data types in Java. Today we are going to look at the primitive integer of type long. So let's get to it. Now the long data type, the long primitive data type in Java, as you can see here, it's one of the 8 primitive types in Java, and it falls under the numeric type, the integer numeric type. And you'll see the long is a 64-bit or an 8-byte signed Java primitive type. Okay, now I'm not going to try and say this long number, so I'm going to go to Google and let the lady tell you. So let's go ahead.
Its range is -9 quintillion 223 quadrillion 372 trillion 36 billion 854 million 775,808 to 9 quintillion 223 quadrillion 372 trillion 36 billion 854 million 775,807.
Okay, so it's a long number, as you can see. And going back to my notes there, easiest is to remember it's from -2 to the power of 63 to 2 to the power of 63 minus 1. Okay. Now, because it's 64 bits, remember it's always one less, because you got the 0 bit to represent bit, and it's a signed number, so you got a negative and a positive. The literals in the range above are called integer literals of type long. Note, of type long, if they end with a small l or a capital L. So you denote integer literal of type long with an L at the end. Integer literals of type long can also be expressed in binary, octal and hexadecimal format. If the literal assigned to the long is not in the valid range, a compiler error is given. A byte, short and an int can always be assigned to a long, and the inverse needs casting. So from a long to a byte, or a long to an int, and so on. A long has a corresponding wrapper class, which his name is long with a capital L, with methods and constants that you can use. Okay, let's start using the long then. We'll start by declaring and initializing a long. So here I've got the block of code in my class, which I've called public class main, and in my main method, what I'm doing here is I'm declaring variables of type long. Num1, I'm just declaring it of type long. In the next line, I'm actually declaring 2 of the same types. Notice the comma there and the semicolon end of statement. And then I'm allocating 12, and I'm ending with an L, which indicates it's a long integer literal of type long. And note, it's not recommended to use a small L, because it can be confused with a 1. It can be confused with 121. This is actually 12. Then look at this line, an interesting one. Assignment works from right to left, although we will look at assignments and operators later on. I'm using it here. So it evaluates from right to left, where usually other assignment is from left to right. So I'm saying 225 with a capital L, which is a integer literal of type long. I'm assigning that value to num3, and I'm assigning num3 to num2. So I'm initializing these 2 values here. Then I'm printing out num1 and num2. So num1, comma, and so num2 and num3, the values that I've got there. Then, yeah, I'm showing you this is an interliteral of type int, because I don't have an L at the end, and I'm assigning an int literal, and because int is 32-bit, and a long is 64-bit, I can assign it without casting. And then I'm just going to output num4 there. So let's save this, and I'm going to just call my terminal quickly. Let me just delete that like that. Okay, so let's see what the output will be of this. Let me put it over there. Okay, so I'm going to run it. I've already cleared it, so I'm going to say java main.java, and it compiled and ran. It's compiled into memory. Okay, so yeah, I've got, you see that value, num is equal to 12, num2 is 225, num3 is 225, which is fine. It's 12, 225, those two, you can see I've assigned them both the same value there, so that's correct. And this integer literal of type int, and those two integer literals of type long, they're working fine. Okay, yeah, I'm showing you how to assign different formats, in other words, the interliteral of type long in binary, octal and hexadecimal format. And note that the capital L at the end, as I mentioned, you could use a small l, but it's not recommended. So note over here, this is a binary because I'm starting with 0b and the binary value of 15, but it's of the integer literal of type long because I've got an L at the end. So that I'm assigning the binary 15 to num5. The same, because this one starts with a 0, it's an octal, and with a capital L, and octal 17 is decimal 15, and I'm assigning it to num6, and this is an hexadecimal format with a F, which is 15, and L means it's a long integer literal of type long. And the last one I've got starting 017. Note this is an integer literal of type int in octal format, because in 8 I don't have a L at the end. It's the same as that one, but where this one is in octal format of type long, this is octal format of type int. Okay, so and then I'm printing it out. Let's just go and see. So I'm going to save it, and I'm going to just compile and run it. So it's java main.java, and there it is. They all to the value of 15. Now the byte, the short and the int, they are smaller than the long, so they will always fit in the long. So let's look at that. So yeah, I've got a code here. I've got -128, which is the smallest number you can store in a byte. Yeah, I've got short, and I'm using its wrapper class to get its minimum value. And for int the variable I, I'm using the wrapper class integer, and I'm getting its max value this time. Then I've got a long num9, num10, num11, and I'm assigning, note here, I'm declaring, just an interesting thing here, I'm declaring num9, num10, num11 of type long, but I'm initializing num11 to an I, so to the max value of I. Then num9 I'm initializing to the B, which is a byte value of -128, and num10 to S, which is the min value of short. Then I'm going to output them over there. Okay, now vice versa needs casting and could overflow. So yeah, what I'm doing is I'm taking an integer max value plus 1 long, so because 1L is a long, so this integer value, the max value plus 1, is out of the range of the integer, but because this is a long here, 1L this will result in a long. An int plus a long returns a long, because the long is the biggest. And because it's a long and I is an int, I'm casting it to an int. And then we're going to print that result there. And then over here, I'm taking 115 of integer literal of type long. And because it's a type long, even though 115 is in the range of an int, because it's an long integer literal of type long, you have to cast it to an int. Okay, and then I'm going to print that out. So let's just run that one and see what happens. And you see there I've got 128 num9, so a byte to a long, the minimum value of the short to a long, and the max value of an int to num9 11, which they're all longs, so that's fine. And then yeah, you can see I've casted the long value max int plus 1, so it's 1 more than the int, but as it's a long, because of 1L, I've casted to an int, and it's underflowed because this was a max value, was a positive plus 1. As you can see, it's this value over here plus 1, so it should be 648, but it's given me an underflow. It gave me a negative number because the long is bigger than what the max int value is. It's 1 above it. Okay, long to int required casting even if in int's range, and yeah, I casted 115 to an int and it gave me 115 because it was in the range, but you still have to cast, but it didn't overflow or underflow. Okay, let's look at the wrapper classes, and we're going to use some methods and constants and so on of the wrapper class, the long class. So I'm going to paste some code here. Okay, a long with a capital L is the wrapper class of the primitive long. It has constants and methods one can use. Okay, yeah, so I've got a min here, and I've copied the min value of the long, and note the L at the end indicating that it's a long literal. Now yeah, I've commented this one because in this case it hasn't got an L. So let's see what happens if I uncomment this over here. So I'm going to take that comment out and see what happens. I'll just try to get my spacing right. Okay, let's save it. And let me say Java main.java, and you see I'm getting an error here. Integer number is too large because this is an integer literal. So this is an integer literal of type int, and we know the int can't have this minimum value. It's giving me a compile time error, so I'm just going to comment that one out because just to show you that it gives a compile error. Then I've got here long's max value. I'm using the wrapper class to get its max value. I typed it as a literal. Yeah, I'm getting it from the long, and there I'm going to output long min and long max. Here below I'm making use of long static class methods. This is a constant, but yeah, a method. Now a method, you'll recognize a method because after the name it's got brackets. Okay, as you can see over here. So what happens here in this case, a string, we will still discuss a string later on, but note a Java string is a sequence of characters that exist as an object in a class in the java.lang.String. So it's a sequence of characters like A, B, C, D and so on, or 1, 2, 3, 4 and 5. A sequence of them. So my name in Java will be a sequence of characters, and if I store it in a string, then that string will contain my name in a sequence of characters. So long's max value is a binary format, is in a string in this case. So what's happening here is long to x, which is a method here, and I'm giving it the 15L, which is an integer letter of type long, and it's going to use that method to return a string representation of that. And here I'm printing it, and here I'm going to use the Long.toBinaryString, where that's 2x, this one is 2BinaryString, and long, and I'm allocating a constant long min value and a long max value, and I'm outputting those. So I'm using the built-in methods in the wrapper class of long, because it's a class with object and so on, more functions that I can do and so on. So I'm going to save that, and let's just compile and run it, and you see there's my long min value, which is this one over here. Then I'm outputting it there. Max value, which I use the constant there, that's my max value of a long, so I've got my min and long value. There is my 15L to hex string. Value of hex string format is F, which is correct. F in hexadecimal is 15. So I was converting it from 15 to the hex value as a string, you can see there. And then my min value to binary string and my max value to binary string, and you'll see there will be 64 bits if you had to count them, and that is my minimum value representation in binary, and my maximum value over there in binary format. Now, like any other of the primitive types, it's like we mentioned, it's got a minimum and a max value, and it must be within that range. So the long is the same, although it's a 64-bit, it still can only have a range of, you heard in the beginning that lady speaking, from a certain amount to a certain amount. So let's go have a look at that. Okay, yeah, I've got an integer letter of type long, because we see the L there. And what I've done here is I've allocated one less. It's supposed to end with 808. As I'm showing the min value there is actually should be the min value should be 808L, and I made it one smaller than that, 809. So then let's just have a look at this specific line here, what happens before we carry on. So I'm going to save it, and let's just run at that one, and you see I'm given error, integer number is too large. Okay, so it's not within the range, so I'm just going to comment this one out. Okay, and then yeah, I've got a long max value, so I've got long 14 with a long max value, and then in the same line I've got num 15, and that one is equal to 1L. So that one is equal to that value, and that one is equal to that one, or both of type long on the same line. And look at how I'm declaring it. I'm declaring both and initializing both, but in this one I don't have to give it a type long because it's over there. Okay, so it's just another syntax you can use where I'm declaring and initializing two variables on the same line as long as they're the same type. Okay, then yeah, I've got long num 16 equals to num 14, which is that one, plus num 15. This works, but an overflow occurs, or an underflow. Why? Because that's already max value, and I'm adding another one over here. These two are within the range at long max value and the long of 1. Now I'm adding the two longs together, and a long is result is a long, But what will happen, because this one is already a max and that one adding 1 to the max, so let's just save that. And I don't have to cast it because they're both longs. Okay, so let's see what happens. And as you can see, I'm just going to bring it there. You can see that num14 is that the long's max value, it's this long number here. Then plus num15, which is 1, which is that one. And now that's a positive plus 1, and I'm getting a negative. I'm actually getting its min value, so it's underflowed, or if you want to call it underflow or overflow, doesn't matter. So it automatically underflowed, where this one wouldn't work because the compiler knows already it's not in its range anymore. These two are in the range, but when you add them together, they will overflow. Okay, so we've come to the end of this lesson on the long primitive type. We looked at the primitive integer literal of type long. We declared and initialized variables of type long. We used integer literals of type long in decimal, binary, octal, and hexadecimal format. We also looked at the long wrapper class and the range of the long. I hope you enjoyed this lesson. Please send me your comments in the comment sections. Like this video. Don't forget to subscribe and press the notify button so that you'll be notified when I post new content. I've also got a Facebook page related to this channel. Lastly, thank you for watching my video and have a great day.